So kind of the plan for today, I'm going to talk a little bit about who Inside Analytical is, and I apologize always to the people who've been on here regularly, because I always go through the same little diatribe about who we are and what we do. And then I'm going to talk about the Process Insights product line. And you can see when I say there's a lot of material here. We're going to talk about extract mass spectrometers, the COSA combustion analyzers for Wabi Index and Carry, the Zentar dew point products. Atom is in the Process Insights line, Atom Instruments, and they do a total sulfur analyzer for gases and for liquids. Sorry, I'm always a guy who forgets to turn off the sound on his phone. Liquids Applied Research, they do water quality analyzers, mostly total organic carbons, biologically organic carbon, things like that, or biological oxygen demand. Tiger Optics is a spectroscopy-based device on cavity ring down spectroscopy, can do down to parts per billion level of detection limits. Commonly used in the semiconductor industry, but some oil and gas applications here again. Alpha Omega is oxygen analyzers. MBW is dew point, lab dew point analyzers and dew point calibration systems, and hydro control is relative humidity analyzers. So we're going to try to touch on all or most of these. So a little bit first about who Inside Analytical is. We're a Calgary-based systems integrator and distributor. Our primary office is a shop in Northeast Calgary, about 20,000 square feet accessible, large systems integration area, 9 bay doors, 10-ton overhead crane. We can easily bring in a full analyzer building on the crane straight off the back of a flatbed truck and put it back out onto the truck after completion. For the Canadians here, especially the guys on the process side, they're familiar with, the fact that Canada seems to think it has to add in extra sets of laws about lots of things. And one of them we have is a pressure equipment, the equivalent of the European Pressure Equipment Directive. And it's the CRN number, Canadian registration numbers for pressure vessels. And so we do AB83 fully compliant fabrication, so we can build complete systems that meet that pressure directive with the appropriate certifications. And we've done that for Alberta, BC, Ontario, Saskatchewan. A lot of the folks that are here are people I've worked with for a long time, some of them for several decades. A lot of us come from the Amitech Western Research background. And a lot of that team that I've worked with over time has come over here. And so, our draftsman has been doing technical drawings for analyzer integration projects for probably getting over 35 years. A few of us have 30 plus years experience. And so we bring together a pretty strong team, even though Insight's only been around since 2015. A lot of us bring a lot of experience from other analyzer manufacturers, systems integrators, and have applied all of that knowledge to the projects that we do. Journeyman electricians on staff, we do full factory acceptance tests here in Calgary. We have a pretty full systems integration capability, from simple sample systems or customized sample systems to full process analyzer integration, PLC and automation projects to full analyzer buildings. Some of you may know me from teaching the process analyzer sample systems course. And we try to help train other people on how to properly do analyzer sample systems. So we feel it's one of our areas of specialty, and it's one of the values that we can provide to our customers is to integrate systems with sampling components that are actually going to allow them to get a representative sample and make systems work. We will work on projects right from the front end engineering design. So we'll look at potential analyzers for use in specific applications, which ones might be best suited, to rate what the cost of those, approximate cost of those are going to be, right through to detail engineering, fabrication, site commissioning, And service is a big deal for us. We run service now out of Calgary, Edmonton, Grand Prairie. We were just having a meeting yesterday and probably talked about adding 2 more people into our service team, because we really feel that it's especially important for a lot of these more difficult process applications where there's complex samples to deal with, that adequate service is available, and customers have a place they can come to directly. So although we rep a lot of products, we try to focus on the idea of getting our service team down to the factories, get them factory trained, and be able to support those products in the field. So Process Insights. Process Insights has brought together a number of companies in their portfolio of analytical solutions. And as you can see, they're kind of targeted around a specific sort of set of applications. And they provide, Process Insights provides, premium analyzers, ensure safe operations, and usually increase production quality. So there's also the environmental side, fits on the safety side. Turnkey analytical instrumentation, cover many industries, very application focused. So in the analyzer business, you'll often see people, especially who are doing R&D, coming out of universities, and they come out with this latest new technology, some type of spectroscopy, a lot of times these days, or some solid state sensors, and they say, well, we can do everything. It's very difficult to do everything well. So one of the strengths, I think, that Process Insights has had, and with the companies under their umbrella, is that they've stayed application focused and said, we're going to look for specific solutions to common problems that occur in industry and help facilitate making measurements that allow those industries to run better. Reputable brands, highly differentiated products, a commitment to innovation. As you see, they'll have, we're going to talk a little bit about 3 new products that are coming out this year, and a worldwide sales and service team. So the core technologies and companies we're going to talk about today are shown here. LARDA's water quality analyzers, mostly for total organic carbon, biological oxygen demand. So I'll talk about where those fit into some applications. Hydro control, relative humidity hygrometers, Tiger Optics. Again, for those of you who know me, usually know them, I'm a spectroscopist by trade. So when I see companies like Tiger Optics, I get kind of excited. This is a laser-based gas analyzer using a technique called cavity ring down spectroscopy, and allows them to do detection limits, in many cases down into the parts per billion level, even into the parts per trillion levels, with high accuracy, high repeatability, and good response times. The COSA and Zentar product lines, or COSA Zentar, has both sensors for moisture analysis and for dew point analysis, but also uses oxygen consumption as a way, in the analyzer, as a way to measure oxygen demand for combustion furnace. So these will provide things like combustion air requirement index or WOBE index for controlling burners, boilers, turbines, etc. Any place where you have kind of a variable fuel is where a WOBE index analyzer kind of fits in. Atom Instruments does total sulfur and total nitrogen analyzers, again, based on a spectroscopic technique. They use an excimer light source and UV fluorescence to be able to measure these chemicals in both gases and liquids. Alpha Omega, trace and percent oxygen analyzers, mostly for process safety applications, glove boxes and things like that. Extrel is an interesting one for me. When I started talking with the Process Insights people about working with them, it was pretty exciting to get the opportunity to work with Extrel. They've been a company with a long history back into the 60s. But the big thing for me was, before they became Extrel, there were a company called Extra Nuclear. And when I was doing my graduate work in chemistry, which with the amount of white hair I have, you got to realize was a long time ago, This is early 1980s. I was using an extranuclear mass spec in the lab. And so I've got a long history with mass spectrometry and specifically the companies and technologies that came to be XREL. And so when we start to look at process mass spectrometry, these guys really made that industry. They were, for quite a while, you kind of sort of thought, well, there's XREL and maybe a few others. It was almost the only name that was known when it came to mass spectrometry. So it's kind of an exciting thing to me. It brings me back to my roots. It's kind of like, when you get to be an old guy and you think, God, I want to drive a 67 Camaro. Again, it's now I get to say, hey, I got to have an XREL mass spec at my shop. It's like back to grad school days. So not saying anything else that we're not excited about all the other lines, but for me, I've got kind of a personal history there. And then MBW calibrations, they do precise humidity measurement and calibration systems based on chilled mirror technologies. These are mostly used for lab calibration type applications. So we are going to take a look at these product lines in a couple of different ways. And one of the things we've always tried to do when we do these presentations is stay more application focused than product focused. And so when you look at the range of products that are in the Process Insight lines, you'll see that most of them fit into doing moisture analysis, oxygen analysis, heating values, combustion control, combustion air requirements for burners and things like that. Compositional analysis, full chemical compositions. One of the things with mass spectrometers is that they allow us to do very sophisticated analysis, multi-component analysis in pretty near real time. They're a very fast analytical technique. They don't, unlike say a chromatograph where we have to wait for all the components to elute, everything's put into a mass selective filter, separated out by its molecular weight, and then can do a full analysis of the entire chemical composition. We're going to talk a bit about some of the flare applications, again, being driven in the US, where they'll do a full speciated hydrocarbon analysis, calculate BTU, and also do a full sulfur speciation analysis as well, H2S, COS, CO2, methyl ethyl propyl mercaptans. Fast compositional analysis. We talked a bit about on the last slide about staying application focused, and LAR is a very focused company on looking at hydrocarbon contamination in water, whether it's in wastewater, water purity systems, but their technology has really been primarily built around the measurement of how much carbon is in the water. And people will talk about things like total organic carbon, biological oxygen demand, and it's really a measure of how much hydrocarbon contamination have I got in my water. It's really important when we look at things like boiler feed waters, because this can be a sign that we have a leak in heat exchangers. And so some process applications, some environmental applications. And there's a lot of the technologies that are in this group of products that are especially applicable to environmental applications. From the atom total sulfur in gases and liquids, it can be doing it in gas phase, in liquid phase, such as LPGs, propanes. A lot of the sulfur dioxide reductions we see have come by as part of tighter specifications on gasoline and diesel, and low sulfur gasoline, low sulfur diesel. And this technology is particularly suited to measuring total sulfur in those light hydrocarbons. In some process applications, in emission monitoring applications, people want to look for very low concentration things of ammonia, HF, H2S as contaminants in systems, and the cavity ring down technology fits in very, very well there. The flare and fuel gas analyzers we talked about do total sulfur as well, speciated sulfur, and this again mass spectrometry. And so a bunch of different environmentally oriented applications. Mentioned briefly that they have a big focus on innovation and new product development, continuous improvement, and several new products from them coming out this year, including the O2CX, which is meant for stack gas or emissions applications from burners, where you can look at oxygen and how much carbon monoxide equivalent you have. And it lets you, if you think about your car, you have an air to fuel sensor, you have an air to fuel ratio that you're trying to run to try to stay at the best or the lowest emissions and get the most energy out of the engine. And it's the same thing. We want to balance the right amount of air for the fuel. And one of the ways we can look at that is to look to see how much excess oxygen there's left over and how much unburned fuel there is. And that's where the COE part comes in. Adam, as we mentioned, does total sulfur and total nitrogen analyzers. From Insight's perspective, we often look at them for process applications and saying, hey, I want to do, I'm running my deethanizer, I make product LPG, I've got a sulfur specifications. But the technology is also used in the lab, and they've got a new product coming out, the XTH, which brings in a new technology which allows them to do heavier and more viscous fluids. And on the side over here, there's an auto sampler, so they can do multiple different samples. So you can set this up in the lab and say, I've got 20 samples of perhaps my diluted bitumen. Then I say, I want to do total sulfur in it. COSA is coming out with a very compact loop-powered little dew point transmitter. All of the COSA dew point sensors are based around this hyper-thin film aluminum oxide type sensing mechanism. And they've taken that, made it more compact, suitable for applications where you're going to need multiple installations. And we'll talk a little bit about moisture measurement coming up. The main sort of target applications we're going to talk about today, and there's certainly, again, when we talk, especially about things like mass spectrometers, there's a lot of applications where they can potentially be used. They're virtually, even more so than infrared, a universal sensor of chemicals and chemical composition. So you could there's probably not an application that couldn't potentially be done with a mass spectrometer. It's just a question of, is it the right tool for the job all the time? But there's certainly a lot of applications where that is the case. But we're going to talk about applications like refinery fuel gases, plant fuel gases, looking at fuel gas composition for sulfur content, for BTU value, and burner controls, perhaps based on that chemical composition analysis. We're going to talk about flare compliance. As I was talking a little bit before we got started, the US EPA has brought in a lot of stringent requirements on flare gas. And it's included both total sulfur emissions, H2S emissions, speciated sulfurs, and full BTU analysis. And again, this is a big application for several of the process instruments products, from the COSA products doing WOBE index or BTU, to the XRL mass spec for doing speciated sulfurs, to the Atom instruments for doing total sulfur measurements. Talk a little bit about process sulfur and liquids as well. Talk about water and wastewater applications with the LAR side of the product line. Another really interesting one where almost all of these products fit in is in this kind of, a lot of people talking about this hydrogen economy. And so what often gets referred to as syngas or synthesis gas, which is usually a mixture of CO and hydrogen. Hydrogen production itself, we see a lot of mass spectrometers in ammonia plants and fertilizer plants. And it's also got a lot of applications on this RNG, or renewable natural gas, biofermenters and things like that. So we'll talk a bit about where these technologies fit into there. Talk a bit about dryers and instrument air, and also the fact that a lot of these products are also available for use for lab analysis. So on the fuel gas side of things, so when we have a refinery, or it could be we have a SAGD processing facility, up in the Alberta oil sands, or we're producing well, we'll often use some of the excess gases from processes, whether it's a hydrocarbon stream that's coming off in the vapor side of part of my distillation tower, whether it's well casing gas coming back from my SAGD wells, but we'll often use some of those gases as a low-cost fuel source for some of our burners. And if we're going to do that, we have to realize that a lot of those gases are highly variable in their composition. Not only that, there's specifications on them for both total sulfur and H2S. If we want to get our air to fuel ratio right in burners, we also have to consider things like net heating values, specific gravity, what's called Wobian carry indexes. So these are a measure of how much oxygen does my burner really need. Again, in some cases, we want to be able to do a full speciated chemical composition. We want to know every chemical that's there. And this can especially be useful when we're doing flare gas in a refinery, because there'll be certain components that we don't always expect to see in the flare. And it gives us a sign which upstream processes may be having problems based on what chemicals, compositions, and ratios of chemical compositions are there. Again, whenever we burn fuel, we have to add oxygen to it. And we want to know if we're adding the right amount of oxygen. So things like the COSA 9610 and the extra mass specs can be put on the upstream side to try to control the burner at the most optimum point to make the best use of the fuel. And for good burner control, we usually want that. We want this feed-forward control idea. Measuring in the emissions is too late because we've already burned the fuel. And if it's highly variable, we won't keep track of changes. But we can put in an analyzer like the O2CX and look at how much excess oxygen there is and how much combustion there is on the vent side, which lets us know how well our feed-forward analyzer is working. So these can kind of go hand in hand in terms of one's trying to optimize the air to fuel ratio before it gets into the burner, and the other one is telling us how well did we do. And so this is, again, when I said earlier on that there's a certain set of applications that some of these process insight product lines have just sort of converged around saying we can provide a total package solution in this way. Things like the Atom SGA 1000 is a fast total sulfur analyzer that lets us measure, are we on spec for this fuel gas? Again, our fuel gases often have a requirement for H2S, or we can have certain process operating conditions that are problematic if we run too much sulfur for them. Some gas turbines have issues with that. Sulfur leads to a lot of corrosion-related issues. And so there's, and if we're using it as a fuel gas, it's the sulfur in the fuel gas is a source of sulfur dioxide emissions for the facility. So we can do combustion control, and I kind of focused a little bit on the O2CE because it's a new product that's coming out. But we have a number of other products here that are all part of that combustion analysis. The external mass spectrometers, the MAX 300, the MAX 1000, can all be used in BTU compliance, in fast flare controls, and give full speciated concentrations. With the MAX 300, we can also add in that total sulfur measurement. The COSA 9610 is specifically targeted towards controlling industrial burners, and especially in places where we can have some variability in the fuel. You know, if we know we're always getting spec natural gas, the BTU range on that is probably pretty tight. And we may think, well, you know, maybe I can run without a feed forward analyzer. But when I start to bring in more variable fuel sources, especially things from refining operations or wellheads, I get a lot more variation in the BTU content of my fuel. That means I have to be able to control my oxygen concentration to deal with those variations. And that's where the COSA 9610 comes in. The atom is in there to provide that total sulfur measurement so that we can make sure that we're on compliance. Oh.
I'm on a webinar.
We'd like to make sure that we're in compliance for our SO2 emissions, and it's part of our reporting. When we look at the way, especially the way the US set up the environmental regulations, they said you either have to measure your SO2 emissions off of every burner that's using your fuel gas, or you measure the total sulfur in your fuel gas, and that lets you predict all the SO2 emissions just by volumetric flow and knowing the total sulfur. So it's certainly every refinery puts in a fuel gas analyzer. Talk about water analysis, fast online water quality analysis. And again, applications all through the industry, ultra pure water, and a relative who worked in the semi industry and said, you know, one of the most corrosive materials there is can be really pure water. And one of the most difficult things to do really good quality measurements is how pure is my water? And this is where the LAR can come in with very low detection limits for how much hydrocarbon or combustible carbons are present in that water. And that's, you know, the quick TOC trace for doing very low levels of organic carbons in water. But we can use these in harsh wastewater streams, in processed water streams, you know, especially boiler feed waters again. This gives us an opportunity to look for things like, do I have a leak anywhere in my I usually have a heat exchanger, and I usually have a source of hydrocarbon fuel, and I can potentially get leaks into my water, and this is a sign that I'm heading towards imminent failure on that heat exchanger. Environmental compliance requirements. Almost all of the wastewater that we emit from an operating facility has requirements for knowing the TOC content. And so it's used across multiple industries, certainly. You know, various analysis can be done. The one that we commonly hear was TOC, but there's a whole bunch of other acronyms that come out there. Chemical oxygen demand, biological oxygen demand. These are all different specification or terms that are used around specifications put on different applications. Again, the big thing is, you know, Insight, we're kind of focused largely on the process side. So we like to look at things like oil and water, cooling waters, condensate returns, steam cycles, boiler feeds. All of those sorts of things are places where the LAR TOC analyzers fit in. Flare gas applications, we see many of the same products that we would use on fuel gas. Again, we have to realize that flares are complex things to do measurements in, because unlike a lot of our chemical processes, which, you know, should run, most of them run fairly stably, Flares are there, flare lines are there to take excess flow from often parts of the plant that aren't running properly at a specific time. It might be a vessel that we steamed out. It might be vent gases that come off of tanks. And so the compositions can be quite variable over quick periods of time. And this is where analyzers like, again, Fast Willoughby Index, the COSA 9610, lets us measure how much oxygen demand is there, and from that, the BTU value. There's a specification on the BTU in flare gas. It's got to be enough to keep the flame going. And so we have a minimum allowed BTU that we're allowed to operate at, and we need a way to determine that. We can also do that with full speciation and do the sulfur contents in the flare as well. And again, this has been huge. When the US EPA brought in subpart JA, it changed the whole thing about flare gas analysis and what we needed to be able to measure in there. And said we had to be able to do a separate H2S measurement, and there were certain sulfur compounds to be included in the total sulfur analysis. And so speciation became important. Other applications is a matter of looking at what's my total sulfur in flare. If I just need to do the total sulfur in flare, the atom provides a simpler solution, doesn't require as many calibration fluids, and measures continuously total sulfur in flare gas. So, again, a number of products around this flare gas application. So we can look at it again in terms of what measurements we need to do. If we're looking at flare gas, we can look at, do we just have to do BTU compliance? Do we want to do fast controls on the BTU content? If so, again, all of these analyzers fit in there. If we want to be able to do H2S and total sulfur at the same time, it's the Xtrol Max 300. If all we're worried about is total sulfur, we can look at doing the atom FGA. The big thing about this is these analyzers have high uptimes. I was just teaching a sample system course down in Ohio. Interesting refinery. I think it was built in the 1890s. It was one of the original Rockefeller Standard Oil refineries. It's moved through a series of ownerships. Currently was with Husky. Husky was purchased by Synovus. So it's a Synovus refinery now. And they have 6 Xtrol mass specs down there in a number of different applications. Mass specs are extremely fast. And so one of the things that they can do is use them in stream switching applications. Again, I don't go into all the features of each of these analyzers, but a common configuration for the Xtrel is to have 16 or 31 sample points. And so this makes it particularly suited. So for example, again, when we're looking at environmental compliance, you have a certain requirement for uptime on your SEMs. You have to be measuring, the EPA says you gotta have a certain number of measurement points operating days and hours within a year. And it's pretty high. Because one mass spec can measure at multiple sample points, what some facilities have done is put 2 of them in, all measuring off the same group of points to go, well, if one of them is done, I've got measurements off the other one. So now I'm sure that I meet my uptime requirements. This also allows us, what we do sometimes to keep that flare burning is purposely add good quality fuel into it, sales quality natural gas, and say, hey, I'm just going to make sure that I've got enough BTUs for the flare to stay lit. We can improve our fuel gas utilization, controls, and consumptions. Steam methane reforming and in general hydrogen production are big subjects of discussion. If you look on any energy forum, if you look on LinkedIn, if you follow any of the renewable energy information, the manufacture of hydrogen and moving to a hydrogen economy is one of the solutions that people are talking about when they talk about greenhouse gas reduction. When we take a hydrocarbon like methane and burn it, we end up producing carbon monoxide or carbon dioxide and water vapor. And this is the enemy to a lot of people these days. So a lot of people are looking towards hydrogen as a fuel for these combustion type operations because we can burn hydrogen and the only thing it makes is water vapor. A number of different ways to make hydrogen, from electrolysis of water, from steam methane reforming. Steam methane reforming with CO2 sequestration is a way of reducing the CO2. You can capture it, don't emit it to the environment, and then use the hydrogen as fuel. However, all of these fuels have their specifications on it. We want to know water content. We want to know things. If we're making hydrogen from a hydrocarbon, we can make carbon monoxide. So we want to know how much carbon monoxide and CO2 is in there. We want to be able to look at the hydrogen purity and make sure there's not unburned methane. If we're looking at landfill gases or biogases from fermentation processes, we're often interested in how much nitrogen is in there and how much oxygen is in there. Because again, when we look at a landfill, there's air present. And so those are specifications. We're only allowed a few hundred parts per million of oxygen to a few thousand parts per million in natural gas pipelines. And then if we're going to use it as a fuel, all these combustion measurements come into play. So there's a variety of product lines in here. Some of the ones we've talked about, the COSA 9610, the external mass specs, there's model numbers on here. There's also a version of the mass spec using a different type of ionization source. So it can go down to parts per billion type measurements. So we can look for trace impurities in these things. If we're looking at trace impurities, the Tiger optics, the cavity ring down spectroscopy comes into play as well. Can you trace levels of moisture, CO, methane, and CO2 and hydrogen? The XPDM, which is one of the Zentar products, the moisture sensors, can do low-level water dew point analysis. And again, when we're bringing, especially things like renewable natural gas and biofuels in, we're going to have to strip all the water vapor that's there out. And we want to make sure we're meeting those water dew point requirements. So if we look at hydrogen production, from any one of a variety of sources. And really, I've got a colleague at one of the engineering companies in town, Mike Wichishin from Corsair, and he's providing me some great information that even though people think the electrolysis is going to provide exceptionally pure hydrogen, but there can be some strange contaminants that show up in there as well. So if we're doing biogasification, we want to look at hydrocarbon compositions, H2S in there. Downstream syngas, when we've run it through the reactors to try to convert the biogas or the natural gas to hydrogen, we want to look for things that didn't convert over. Some of these are a measure of how much residual air got into the system. We want to look at how pure the hydrogen is. And we want to look at things like, did I convert all my methane? Did I convert all my CO? And how much CO2 did I produce? Anytime we make hydrogen, it goes through a purification stage. We're going to try to take things like any CO2 that's in it out, any moisture that's in it out. And so afterwards, after that purification, we want to see, is it actually pure? And this is a place where the Tiger optics can come into play to look for residual CO, CO2, methane, and water vapor. We'll often run this through a cryo plant to separate out the hydrogen from the things that won't condense. And then we're going to possibly want to measure, again, what trace components have made it into my hydrogen, because that's going to possibly go to pipelines. And so this whole subject of moving to hydrogen as a fuel source and putting hydrogen in pipelines, it sounds like a really good idea, and it probably is a really good idea, but there's a lot of complexity along the way. If we had a nice way, we could just say, well, it's really easy just to make pure hydrogen. There's no issues with it. We have to do measurements to determine product quality. And when we're making this a primary fuel source, there'll be a lot of tight specifications put around that. And again, the Process Insights line fits very well into doing a lot of the monitoring that'll be required for that. In applications where we want to produce dry gases, whether it's instrument air for a plant, to whether it's looking at trace moisture in air or nitrogen in a semiconductor facility. Again, moisture is one of the most measured chemicals there is. Really, moisture, CO2, and hydrogen are probably the three most measured chemicals in industry. And whenever we put some kind of a desiccant dryer or a refrigerant dryer, a pressure swing absorption type dryer, we want to do continuous moisture analysis. We can do that down to dew points of around minus 100 degrees C with aluminum oxide sensors. So we're getting down into parts per billion sort of ranges in there. We can go even lower using cavity ring down spectroscopy when we want to do very trace levels of moisture, which we might see at a turbo expander outlet or at some semiconductor type facilities. We've got a couple of different technologies that we can bring to play for those trace moisture applications. And a lot of the product lines we talked about have laboratory available versions of them as well. They have laboratory, they have general purpose type applications. And so for things like ambient air monitoring, air and fence line monitoring, we can again look at the atom for lab analysis of gas samples or liquid samples. For sulfur species, we can look at the Xtrel for a full chemical composition of the air, including trace components. Again, if we use things like atmospheric pressure ionization, we can get down to parts per billion, parts per trillion in a device that can speciate multiple chemicals at the same time. The alpha omega products are primarily used for oxygen deficiency. And so can be used for determining, do we have the right, is it actually air in there? Do we have a safe environment of building for a person to work on? And for calibrating a lot of these equipments, again, in lab applications, the MBW technology is there to both act as moisture generators and a chilled mirror. Chilled mirror is really the reference method for water content and dew point. I think that runs me through most of the stuff I was going to go through today. So I know I ran through this pretty quick. Any questions, happy to discuss them. Again, you know, for us at Insight, we're honored to work with the Process Insights people. I like it, we kind of have the same name in there. You know, it's a big addition to our product line. It covers a lot of the areas that we really work. We cover some of those other areas with other product lines as well. So we just kind of give you an idea of, you know, who else do we work with, what other technologies. We use JP3 for near infrared analysis, mostly liquid hydrocarbons, Z-gas for doing water and hydrocarbon dew points in natural gas, hydrogen, CO2 streams. Inside Analytical is a process oxygen sensor in some applications, and especially for water and liquids. UWT for level, Rigaku for total sulfurs and crudes, for an online total sulfur and crude. We manufacture also our own line of automated samplers, custom, sorry, that's not universal analyzers, guys. Custom sampling system components. We've got our own line of probes, three-way valves, things like that. We do some chemical analysis for pipelines, and of course, act as a systems integrator. But what Process Insights has done is brought in this. And for us, that opens up a lot of applications to work with some of our industrial partners and provide a whole new range of analysis for them, bringing to bear in it the strong background that we have in analytical systems, in sample systems, and in systems integration. So, I know I touched on a lot of stuff. We've got a lot of information about all the technologies we talked about today. I could have done an entire hour on any one of them, just based on principles of operation and applications. What I wanted to do today was give you an idea of what Process Insights brings to the table, what applications their technologies are applicable in. And a lot of people think of us for doing this liquids, hydrocarbon, chemical composition, vapor pressure type stuff. There's a lot more to Insight now than there was a year ago. We want to try to help make you aware of that. Scott and Grace have been doing a great job of getting out and talking to people, but the more we can do this, the more we'd like to make you aware that we may have a solution to a problem that you've been working with for a long time. And we'd love to talk to you about it, whether it's on the biofuels, methane reforming, traditional natural gas liquids, crude oils, and refined fuels. We've got a solution for a lot of the applications that come up in there. As I mentioned, you should get a copy of all these slides shortly, a link to the YouTube video, and at the end, I do give you some contact information for Scott, Grace, and myself. And of course, we try to have a lot of information on our website. You can also follow us as Inside Analytical Solutions on LinkedIn. If you put into the search bar Inside Analytical, we keep a pretty up-to-date LinkedIn page. Has announced all of our webinars there. As you've probably seen, we put them out through Making Measurements Matter as well. Mr. Philpott, you're more than welcome. Thanks, my friend. Thanks for coming by.
Very informative, Phil. Thank you very much. Worth the time.
Yeah, there's a lot of stuff to talk about in there. You have to come by the shop and we should have a chat.
Absolutely.
All right, folks, I think we're going to wrap it up there unless there's any questions. Again, appreciate everybody coming.